Hello, I'm Simon, also known as PyHop. This is a special edition tutorial series covering the new POPs operator family in TouchDesigner while we're still in the experimental build. Today, we'll be looking at how to add color and thickness variation to the trails coming out of the trail pop using the line mat to get something like this. This tutorial uses build 2025.30060. And a fair warning that things will likely change between now and the official release. So my hope is that this methodology can be relatively easily recreated, but there may be differences if you're watching this further in the future. Before we begin, I want to thank all my Patreon supporters and give a special thanks to my top supporters. On Patreon, you'll gain access to exclusive example files and tools. You can vote on future tutorial topics and more. Also, if you're interested in taking this technique further, I've put together a Patreon exclusive video showing how to extend the network to create these skinned 3D tubes, and it uses this tutorial as a jumping off point. So if you're interested, you can find the link to this extended tutorial in the description. And yeah, without further ado, let's get started. Let's go ahead and begin with a sphere pop. So we're going to use this as the starting points, though you can certainly use other points later for experimentation. And the next thing I want to do is animate these a little bit. If we just throw them right into the trail pop, which we'll do eventually, nothing happens. And that's because we need to move these for them to create a trail. This is kind of like a little mini feedback loop that creates trails based on the motion of points. So instead of that, let's add a transform. We'll start by rotating this, and I'm also going to set this entire project up so that it could loop on the timeline, just for fun exercise. And so I'll go ahead and change the end and our end in the timeline to 1200 frames. And then I'm going to put together a quick set of chop channels that can give us our fraction and also a sine and cosine wave. We'll be using the sine and cosine wave specifically when we need to loop noise, which works both for tops and for pops. If you've seen my videos on looping noise, which I'll link to in the description, that's a good reference for this technique. So I'll set the frame, and then also I want the end. So I have the current frame and the length of our timeline. I'll create a math chop. And so for this, set combine channels to divide. Now if I hit A and R to reset that range, we have a fraction for our timeline. Let's go ahead and add a null after this and just call it fract, a shorthand for fraction. And I'll also stem with the middle mouse button to grab a lookup chop, create a pattern chop, drag that into my lookup. And we need two channels here that we want them to be offset 90 degrees in phase. So first I'll create those channels in channel by doing T left bracket, ZW, right bracket. So this is TZ and TW, since those are typically the channels I'll want to animate for our noise. And then under pattern, we can use a 0.25, which is that 90 degrees out of phase, and multiply that by me.chan index. So this says, okay, our 0th channel and then our first channel, it uses those values when it evaluates our phase. So this is a nice way to get that offset in one chop instead of needing multiple pattern chops. I'll go ahead and add a null after this and call it loop. So now we have a couple chops that we can reference whenever we want to loop things to the timeline. So for our transform, we want that frame, the fraction. So I'll drag that into rotate for RY and multiply that by 360. So if I hit A and W, now you'll see we've got ourselves a rotating sphere. Great. So at this point, we can start to add our trails and see what it looks like. I'll go ahead and add the trail pop. And here are our trails. Hooray. So let's go ahead and also change the trail length to 100. You could keep it at 60 if you want. It doesn't have a huge effect. You can play with this later too if you'd like to adjust the length. Now, let's also quickly get that rendering so we can see what it looks like. I'll create a geo comp. And I'll start with the line mat, since that's what we're exploring today. Drop that on and set it to the material parameter. Great, so you can see it's already doing a little bit of the line material in the viewer here. Let's go to line, and you could keep this if you'd like or dial it in, but for now I'm just going to keep this a flat color, set this to white, and same with the width. So I'll set this to 20 and 20, actually maybe 10 and 10 for now. Now let's render this. I think I dropped a reorder. Let's render this. And I'll drop down a camera. Cool. Let's set the resolution to 1080 by 1080. Drop an out and set the viewer flag to display. I'll split this screen, the panes. You can do that at the top right, split left right, or alt left bracket, and then alt 4, or drop down on the left here and choose top viewer. And I want to right click on the left and change the display so that I do not show backdrop tops. Great. So a couple other things here. I would like to add a black background. I'm a fan of the constant top here. I know there's, some people like chroma key and other things, but I think it really gives a clear idea of like what I'm doing in this operator. And I also have the affordance of changing the background color to anything I want beyond black. So a couple extra steps, but I like the legibility and the flexibility. I'll take the operation to over and swap the order. So now I'm compositing it over black. A couple of the things, let's add a null comp. And for our camera 1, drag that onto the look at. And now I'm going to change the translate to 222. I sort of like the top angle, gives me a little more dimensionality of the sphere. Let's also add an SSAO, or screen space ambient occlusion top. This works okay with the line material. It definitely adds more artifacts, I think, than some other materials, but it can still be a nice way to add some kind of nice depth effect to it. So I'm going to dial the blur radius down. You can already see how kind of crunchy this looks, but depending on your hardware, you might also want to dial some of these effects down a little bit. But I'm going to bring the sample directions all the way up. Sometimes I go further than this, but for the tutorial, we'll keep it at 2030. Bring the surface of void down to say 13. Pass resolution full, so it already looks a lot better. And then I'll bring up the radius slightly and the contrast down. So it's a subtler effect. And while you can still see the crunchiness a little bit, especially once we add things like bloom, it'll be a lot less obvious. Cool. So speaking of bloom, we're going to drop this in, and it's not going to look great right now because, well, it's pretty intense because we haven't colored our lines yet. But we'll come back to this a little bit later. I can sort of pre-dial it in around where I know I want it, around 0.4. I'll bring down the radius, the min and the max bloom radiuses, and yeah, dial that in. But for now, let's bypass it, and we'll turn it back on once we've added color so that it's not kind of overwhelmingly glowing. So yeah, we've got our line material, great, but let's spice it up a little bit. One thing I want to do is animate the position a little bit more than this simple transform. So before the transform, really either place we can do it, but let's add a noise pop, and I'm going to call this noise underscore position just to tell me, okay, that's what I'm doing with this noise. And I'll create a select chop and then grab those looping channels from our loop null, add a math chop and a null. So this structure is one I use pretty often with this technique. I'll use the math to adjust the multiply of those channels, and that will determine how fast my noise is animated, whether it's a pop or a top. So I'll open up the viewer here and drag these into transform. Here I'm going to use the export for both TZ and translate 4D. And the reason I like the export is it makes this structure more copyable. If I simply use the kind of expression and I copy and paste it, it's still going to grab these channels from null 2, and I'll have to keep updating those values. But now if I copy and paste this, you'll see that that relationship stays constant. And so that's kind of one instance where I like to use exports over expressions, is when I want to be able to copy and paste a structure like this. So you'll see that it's already doing some squiggling. Great. we want it to animate like this. And let's change some of these values in our noise. So I'm going to go ahead and change my period to 2, and let's see what else. The amplitude, let's make it a little more extreme, close to 0.4. Now it's like a little wild, but I think one thing we can do then is for our mult add in Math 2, kind of bring down the level to say 0.3. So that's looking good, and I think it'll serve us well later. Another thing that's totally optional, but the output, and this, I don't know if this will change, on our noise position, our noise pop here, is adding a noise float, which we don't really need this, so I can actually turn that off and just keep the combine operation happening. One thing I've noticed too is it doesn't really matter if I change the noise size, so I'm not sure if that's actually a bug or not, but it might be in the future that this needs to be set to a vector, or it might automatically be requiring that because my position attribute is a vec3. So it's hard to say, but that's something to definitely look at, is this scalar versus vector, which will determine whether your noise is a float or a vec3. So yeah, in this instance, we're good though. This is doing what we want visually, so we can leave it either one. And yeah, so we've got our animation, our position animating, but let's add some color. I'm gonna give myself a little bit of space here after the trail. And after the trail, I want to add a line metrics pop. This is a really useful operator to use in conjunction with trail, but really anytime we have line strips, it can give us a lot more information about them. And specifically in this instance, we want the distance start normal, which gives me a value on each point. It's a point attribute, and it tells me the normalized, a normalized value that represents the distance to the start of that line. So at the beginning it's 0, at the end it will be 1, and it doesn't matter how long that line is, our values will always be between 0 and 1, which makes it really useful when you have an attribute that you want to map over the course of that line, even when the length of the line is changing. So to add color, first we need some color. So I can start with a ramp top, and I'll give it a, let's see, kind of like a gray to start, and then let's say kind of a purple, and then a darker purple. Cool, we'll start there. And I'll drop a null after that and call this color. And from there, let's add a lookup texture. I can drag my color onto top. I'll choose distance start normal for our lookup attribute U, and for now, I'll delete lookup attribute V. Let's go ahead and set our output attribute scope. Until we do that, this isn't doing anything, but let's change this to color. And now we're coloring our lines. Hooray. You'll notice something funny at the caps, and that is because the input extend mode is repeat, so it's actually interpolating between the start and the end of this color. If this actually looped like this, we wouldn't see that issue, but if we wanted it to have a different color at the start and the end, we just want to make sure this is set to hold. And that goes away. Cool, so the next thing I might want to do is add a line width, vary the thickness of the line over the course of the line. And if you wonder, how do you know what to name that? I want to point out in the line material, there is this attributes tab now. where you could even say, I want to use a different attribute for the position. But it also has the color. The color is pretty much a reserved attribute. It's like what you're going to want to use for color. And then also line width is something that you'll even see in this dropdown as suggested attributes. So those don't exist yet, but it's saying, oh, you might want to use line width because that's a standard name for that attribute. So we'll go ahead and create ourselves some line width attributes. So one thing we could do is repeat the same process that we did for the color. I could even copy this and maybe I'll name these so that it's a little clearer. So this is lookup text color, and this is lookup text line width. And then I need to make sure I call this something useful, line width, and yes to all. And then for ramp 2, let's make this a value that goes from 0 to 1, and then back to 0 again. I'll set it to ease in, ease out. Let's also change the resolution to say 1080. And actually bring this in line. And then for output attribute scope, let's choose line width. And it did work right away. So actually we have now a varying profile where it gets thicker and then thinner over the course of the line. But it's giving us a little bit of a warning here. It says not enough output components, ignoring extra input components. So this is referring to the channels. We have 4 channels coming in RGBA, but we only need 1 going out. Line width is a float. And so we're going to just disable G, B, and A for the channel mask, and that warning goes away. And here I might now increase my line thickness a little bit. I think it looks nice when they're a little bit, like they bulge a little bit more. Cool. We can enable our bloom as well. Oh, it's way intense. Oh my God. So I'll dial that in a little bit. Wow. Okay. Yeah, there we go. So this you can dial in as you will, but yeah, just to give it a little bit of a glow there. And this will certainly, change with your color. If you're like, oh, it's going to be pure white, you might adjust that, or if your colors end up being brighter or whatnot, those very much go hand in hand. So yeah, the line width, let's jump back here now that we have our bloom enabled again. And something else I think is fun is combining, say, this profile that goes from 1 to 0 to 1 that gives us this shape with another form. So we could use another ramp. This one set to 1/10, so we have a bunch of little bumps, and then making the minimum not 0, so it's actually not going all the way to 0. And then multiplying these. So we have a little bit more complexity in our profile. That's how I get this kind of streamer-like look. And you can change how the period repeats for kind of a different quality here. But I do like that you can get kind of some nice forms this way. Yeah, another thing we could do with the line thickness or the line width, if we set it back to, say, a consistent profile like this, is to animate values before the trail. So there's almost like in that feedback loop, we're kind of varying it and adding a little bit of like change over time. So for this, we can go ahead and copy that same structure. So I'll go ahead and even drop this in line. It's not going to be happening right now. It's animating the position even more. But we'll rename this noise_line width. And then let's see. We need to go to the output. And instead of adding to combine the operation, I'll turn that to none. I don't want to combine it with my position. And I'll turn noise on. And in this instance, let's call this line width, but we don't want to call it the same thing as our line width. Let's underscore and then write, say, noise. So I know this is noise. It's associated with that attribute. And now maybe increase the multiply a little bit so we're animating it faster. And we also are going to multiply this by our profile. And so the offset needs to be maybe 1. Could make it 2 even for something more dramatic. No, actually, let's make it 1. We'll make it 1, and yeah, keep the amplitude so that it's not necessarily going to go all the way to 0, but we can get smaller. So that sounds good. If I middle mouse, you'll even see we should have line width and then followed by line width noise. And both of those are floats, which is good. Now, to combine those, there's a couple ways to do it, but I'm going to right click and add a math mix. Math combine would also be appropriate. And under combine, I'll choose A times B, line width for the scope A, and then line width noise. And so now you don't see a really dramatic change. So we can go back to our line width here and maybe animate this like way fast. So multiply this by 30. And now, or even 20, here we go. Now we're really like varying that value significantly. And so we get this kind of like jagged quality, which I think is fun. So yeah, if we combine these, which we can, it gets like real wobbly. And you might say, oh, combine this with say 1/3 for the period. It's a little bit more like, I don't know, less intense. But I think there's a lot you can do with these different techniques. Cool. So that's a couple ways of varying the line width. I wanted to show an additional approach for varying color even further by making use of this lookup attribute V as well to combine multiple color palettes using noise to select between them. So to do that, give ourselves a little space up here. First we want a texture that has those two gradients combined. So I can go ahead and copy my ramp 1, make some changes to this. So maybe I make it kind of like a greener blue. Might have to dial this in later. And then let's add a matte top. So this will let us mix between these two inputs based on a channel from our third input. It's giving us a warp error because we don't have a third input here. So let's copy and make this a third ramp. And this one, let's go from 0, so black to white. And I'll add an additional stop here at the beginning and the end. This can be used to sort of create kind of start and stop areas that are consistently one ramp. And I'll make this a vertical ramp because we want to mix these in the direction that they're not going. Drop this into the third input and then change this to red for the matte channel. So right now it's actually probably sampling this middle value, but we're going to go ahead and create a new attribute that can be used for our lookup attribute V. So I'm going to do this as well before my noise position is animating the position. It'll give us just a little bit less to contend with when we're sampling our noise with that lookup attribute. But you can explore where this fits into the network and see for yourself kind of how it affects things. But for now, let's stick this right at the beginning, or it could go after line width. It doesn't really matter in this instance since they won't affect one another. And we're going to use the lookup attribute P, but for our output, instead of line width noise, let's call this color lookup, maybe with capital C. And for our noise, we do want to drop that transform, that math multiply back down to say 0.3. I don't think I want it to animate quite as fast as this width. And then I'll change this to noise color. And let's see, for our amplitude, 0.5 and offset 0.5. We want these values to go roughly from 0 to 1. We can keep most of the other information the same here. Now jumping back to our color lookup texture. Now all we need to do is choose color lookup. And yeah, now we have a nice variation between some sections of the sphere are like that purple color and some are the green, and it's actually happening before all of the animation. So even though we're like rotating this, those points are being colored independent of the position translation. So you're not going to see like one section of the sphere as one color. It's like you can follow one specific trail and it'll still animate based on this animation here, but it's a little different than, say, putting it afterwards where a specific point in space is always a color versus that trail kind of keeping that color, but based on these animations. So if we actually, completely turned off our animation, you should see that a given trail keeps its color throughout its entire path. So different techniques. There might be instances where you want to go about it the other way, but I just wanted to point out this order of operation that can be handy, especially when values depend on your position. And that's it for the tutorial. If you're interested in taking it further, you can find a 3D tubes technique on my Patreon, which jumps off where this tutorial leaves off. It's a great way to get beyond the relatively flat but stylized quality of the line mat. So you can find the link to that in the description. And either way, I hope this tutorial provides some inspiration as you explore the Pops experimental build. So yeah, that's all, and thanks for watching.